Welcome to the Robot Lab Live. Today we're in the Intelligent Automation Lab at Cranfield University, and this is our third trial demo, looking how actually psychologists work with robots. Well, not exactly directly with robots, but how they observe and investigate how people would like to work with robots, what do they want from the robots, and how that future between technology and human together, how it could look like. So my name is Veta, I'm a psychologist, and I have a participant, Zoe.
Hi, I'm Zoe. I am a research fellow at Cranfield University, and I have not really had very much experience with robots at all.
Great. Yeah, that's perfect. Because previously we had Samal, and Samal is pretty experienced with robots, so she's our robot expert. So what we have on Zoe, we have a headband, which measures brain activity, and also wrist-type device, which tracks heart rate and electrical conductivity of the skin. And I'll talk about those measures when Zoe will be performing the task. In addition to that, Zoe is wearing eye tracking glasses, and the glass is actually capturing where pupils are looking, how long they are focusing on particular aspects. So for example, on the screen now, you can see where Zoe is looking, and those green yellowish dots is actually where the pupils are, where they are focusing, where is the gaze going in general. To start with, the task, what I'm going to ask you is industrial type human-robot collaboration. So this is a collaborative robot. It's safe to interact. It has softer skin. It has lots of sensors around to make sure that people, when they are working with robots, everything would go well. And in the task, you will need to press the button, and robot will go and collect the components from robot's desk, bring it back to your desk. And then once again, you will press the button and robot will collect second component. While robot is doing that, you will start the assembly process. So you will need to assemble all those three components into L-shaped component part. Should we try?
Sure.
Okay, so whenever you're ready.
Okay.
Yeah, just go. So, and what you can see now on the screen, you can see actually split screen into 4 different, well, 5, 6 different sections. And the top sections are showing me and Zoe, also the robot gripper, just showing what is happening at the moment in the lab, in the behavioral measures. At the bottom screen is actually that interesting part, which I'm very excited about. And what do they show? So looking at the left side, it's the eye tracking data. And as I mentioned previously, the green dots are looking where participants are looking. So where is their gaze moving, how long they are focusing on different parts. It also provides information about saccades. So saccades are intervals between blinking, and together all this information allows us to conclude about if participants feel bored about the task, do they feel engaged, involved? It might indicate that they feel some emotions, some emotional arousal. Sometimes it is fear, anxiety, because they are not certain about what the gripper will do, how safe it is to interact. So eye tracking is a good way of visualizing all the information what we can capture from participants' gaze. Towards the right side, you can see 3 different graphs, but the middle section, those lines are coming from the headband device, the one which measures brain activity. So whenever different brain areas are involved in a task, they get more of oxygenated blood. So what you can see actually with the red line. And when particular brain area is not involved in a task, it gets more deoxygenated blood, so the blue line. And activity in those areas can indicate actually how people are feeling towards the task. And the final 2 graphs on the right side screen, they are capturing the data from the wrist type device. So the top one, it is more stable line, and it's looking at electrodermal activity of the skin. To put it simply, it's actually whenever we get strong emotions, skin starts sweating a little bit more, and the device captures that by increased electrical conductivity. At the bottom, that's the heart rate, that both of them relate to stress or distress. Heart rate is more related to physical stress or physical distress. EDA, electrodermal activity, is once again looking also at stress, but from a little bit different angle. So it's related more to social stress. As a psychologist, I'm more interested in numerical data, which is just behind all those nice graphs, and just comparing different conditions or different people. So, for example, novices and experts, and looking how they're feeling while interacting with this big robot. Does their trust change? Does it develop? Do they start mistrusting robot depending on their behavior or not? And obviously, all that numerical data can't give me all that colorful information. It just gives me about the changes between conditions. But that's where it's very important, actually, that participants, that after the task, we would have interview and talk actually how you're feeling. And that gives the color to all those numbers. So to start with, you completed this task for the second time. How was it now?
I was still never quite sure where the dropper where it would stop. So I was kind of like, do I go? Do I not go? So I expect my brainwaves were showing something.
And probably I
nice,
gaze focused on the gripper. What would you change with it to feel more comfortable or less bored, actually?
Less bored. Maybe to be able to adjust the speed of it, to have a better idea of where the gripper is going to stop. For instance, like if it was marked on the bench, I'd know where to put my hand. I don't know when to expect it to stop. And then I can sort of plan my next move kind of thing. So I would say those two things at the top of my head.
Yeah. So this actually very nicely illustrates how we can look at physiological data and then talk actually what, in this case, what Zoe would like from the task, and see if actually before grabbing the gripper, if heart rate or skin conductance increased, where she was looking, and then make conclusions that, okay, maybe actually putting a tick or something on the desk to expect where the robot will drop the component would make you feel more comfortable while working with this type of robot.
Yeah.
What attracted you as a psychologist in the first place to start working in the field of robotics, and what were the main challenges that you faced along the way?
I have a serious answer and I have a truthful answer. So I'll start with the truthful one. Is they are amazing things and it's so fun to play with robots. And that comes to a more serious answer, which I give normally to serious people, is that is really exciting actually to be part of developing the future. And as a psychologist, quite a lot of areas are theoretical and not so applied. But here in engineering, working with robots, actually all that psychology knowledge I gained is very much applied, and I can see actual impact. I can see how my results, how our lab results, what we're doing is actually employed in real world, in real environments, how it changes people's lives. And it's in particular, it's interesting when talking with operators from manufacturing, the ones who had experience with conventional robotics, where robots were segregated, and they actually were fearful and anxious about those kind of robots. And now with new generation of robots, those collaborative robots, and people can enter the cell and can work with the robot, and suddenly their whole perception about the robot changes. And it's so exciting to see that change from being afraid of robots, unsure about technology, to actually becoming interested in technology and seeing the potential benefit and upskilling. So I guess it's lots of excitement. That's why I'm working here. Is it comfortable to wear all physiological measure devices, and does it influence performance?
To start with, of course, it's a little bit uncomfortable, but when I was involved in the task, I didn't know that I have these
Yeah.
at all.
So it's easy to forget as long as
exactly.
you are.
As
Yeah.
long as you are indulged, it depends how much involved you are in the task, and you will understand it from my measures, whatever you are
Yeah.
recording at the moment. So I think that will be
That will be very
Right.
interesting to compare two sessions and actually
Exactly.
different participants.
Yeah, because the task was a little bit different.
Yep.
And how I was expecting different parts to be. I think that was really good for me, because I thought the task would be exactly the same. But if it is different, of course, it will bring up different measures, and it's a really good study
Yep.
to understand it as well. But thank you very
so much.
Thank you.
So what would be your advice to give to somebody who would like to switch from a different discipline into working on robotics research?
To be honest, I don't think you really need to switch a lot from a discipline, because robotics is such a multidisciplinary field. So yes, we depend on engineers or computer scientists, but also we depend on psychologists, on social scientists, on philosophers, on designers. Everybody actually can come and tap into this, because everybody's skills and knowledge are really useful. And it doesn't matter what you study. If you are interested in technology, definitely there will be an application and your knowledge will be useful. And yeah, robots, they are coming. It's actually our future. In one way or another, we are going to see them every day in our lives. So now is the best time actually to come and influence the research and shape the future and make sure that people are actually happy and technology benefits them, instead of just technology is being dropped on people and people don't want to work with it. So yeah, doesn't matter what's your field, just come and join us. Okay, thank you very much for everybody who attended, and thank you for whole team. So I hope you enjoyed it, and see you maybe next time.